Have you ever wondered how space telescopes capture stunning images of the cosmos? It's a question that has intrigued many of us, sparking our curiosity and fueling our fascination with the universe. It's not as simple as pointing a camera and pressing a button. Oh no, the process is much more intricate, involving an array of advanced technologies, meticulous planning, and a good deal of patience. Two of the most remarkable tools in our astronomical arsenal, the Hubble Space Telescope and the James Webb Space Telescope, have been instrumental in our quest to understand the cosmos. These space-based observatories, orbiting high above the Earth's atmosphere, deliver images that are simply out of this world. But how do they do it? How are these celestial snapshots taken millions of miles away from the nearest photographer? Well, it's a process that begins with careful planning. Astronomers must decide what they want to observe, when they want to observe it, and how they're going to observe it. This stage is crucial as it sets the stage for everything that follows. Next, the telescopes themselves come into play. These aren't your average backyard telescopes. They're equipped with incredibly sensitive instruments designed to capture the faintest glimmers of light from distant galaxies, nebulae, and stars. Once the observations have been made, the data is sent back to Earth. This isn't just any data, though. It's a treasure trove of information, containing everything needed to construct a detailed image of the observed celestial object. But before that can happen, the data must be processed, analyzed, and interpreted. This is where the real magic happens. As you can see, capturing images of the cosmos is a complex, multi-step process, one that combines the best of technology, science, and human ingenuity. It's a process that allows us to peer into the depths of the universe, revealing the beauty, mystery, and wonder of the cosmos. So how do these celestial photographers capture the universe? Let's dive into the process. Space telescopes, like Hubble and James Webb, are our eyes into the cosmos. But how exactly do these magnificent machines capture the breathtaking images that we marvel at? Let's delve into the science behind it. Space telescopes operate on a principle as old as the universe itself: light. Everything we see, whether it's the glow of a distant galaxy or the twinkle of a far-off star, is light reaching us from across the vast expanse of space. These telescopes are essentially giant light buckets, collecting photons, the fundamental particles of light, from celestial objects. Now here's the fascinating bit. The light collected by space telescopes isn't just the regular light we see with our eyes. It encompasses a whole spectrum, from radio waves to gamma rays, each type of light providing unique information about the universe. This is why some space telescopes, like Hubble, are tuned to capture visible and ultraviolet light, while others, such as James Webb, are designed to capture infrared light. Once these telescopes have collected the light, they focus it onto a detector, typically a charge-coupled device, or CCD for short. These CCDs are incredibly sensitive and can detect even a single photon. When a photon hits the CCD, it excites an electron. The number of excited electrons corresponds to the intensity of the light, and this pattern of excited electrons creates an image. But we're not quite done yet. This raw data is still in an unusable format. It needs to be converted into a digital format that can be transmitted back to Earth. This is done using an analog-to-digital converter, which turns the analog signals from the CCD into a digital format that our computers can understand. But remember, all this data is still just numbers and pixels. It takes the work of talented astronomers and image processors to transform this raw data into the stunning images we see. Now, you might be wondering how these telescopes know where to look and what to capture. Well, it all starts with a plan. Capturing images of the cosmos is not a random act, but a meticulously planned one. It's a bit like preparing a detailed itinerary for a grand space journey, where the destination is often billions of light years away. Astronomers start the process by selecting targets. These could be anything from distant galaxies, nebula, stars, to other celestial objects that pique their curiosity or hold answers to the universe's profound questions. The choice of target is influenced by many factors, such as its location, brightness, and the scientific value it offers. For instance, a nebula where stars are being born might be chosen to understand the stellar life cycle, or a distant galaxy might be selected to study the universe's evolution. Once the target is chosen, the next step is scheduling observations. This is no easy task. Imagine having to coordinate a photo shoot where your subjects are constantly moving, and so is your camera. Astronomers need to account for the Earth's rotation, the target's movement, and the orbit of the space telescope itself. They also have to consider the best time to observe a particular celestial object. For example, some objects are best observed when they are in a specific position relative to the Earth and the Sun. But the planning doesn't stop there. Space telescopes are highly sought-after resources, and their time is precious. So, astronomers often have to coordinate with other teams who might be observing the same or nearby targets. They ensure that the telescope's time is used efficiently and that as many scientific questions as possible are answered. This intricate dance of planning and coordination is crucial. It ensures that every moment, every photon of light captured by the space telescope contributes to our understanding of the universe. It's a testament to the dedication and meticulousness of the astronomers who are helping us unravel the mysteries of the cosmos. Once the plan is in place, it's time for the telescopes to do their job. And that's when the real magic begins, as these space-bound marvels start capturing the awe-inspiring beauty of the cosmos. With a plan in hand, the telescope springs into action. The dance begins. Imagine the telescope, a silent sentinel in the void of space, pivoting with precision. It aligns itself to the coordinates of a distant nebula, galaxy, or star, each a celestial masterpiece waiting to be captured. In this cosmic ballet, the telescope plays the lead. It is not just an observer, it becomes a participant, engaging with the universe in a way we can only dream of. The telescope, programmed with the data from meticulous planning, knows exactly where to look, when to look, and how long to look. As the telescope settles into position, it begins acquiring multiple exposures. It's akin to a photographer taking several shots of the same scene, each with different settings to capture every possible detail. These exposures are not mere seconds, but can span minutes or even hours, drinking in the faintest whispers of light that have traversed the cosmos for millennia. In the quiet, the telescope works, its detectors sensitive to the faintest glimmers of light. The photons, particles of light, journey across the universe, finally ending their voyage upon the telescope's detectors. Each photon's arrival is meticulously recorded, transformed into an electronic signal, a language we can understand. Once the telescope has gathered all the necessary data, it begins its journey back to us. This is no simple task. The data, a treasure trove of cosmic information, must traverse the vacuum of space, survive the interference of solar radiation, and reach the antennas on Earth undistorted. The data, in the form of radio waves, is received by ground stations scattered across the globe. These stations, our cosmic mailboxes, are our link to the universe, the bridge between us and the stars. With the data safely received, the telescope's job is complete. It has captured the cosmos, frozen a moment of cosmic time, and delivered it to us. But the image we yearn to see, the stunning vista of the cosmos, is not ready yet. The telescope has done its job, but the image is not ready yet. It's time for some cosmic processing. The raw data from the telescope is just the beginning. Once the space telescope captures the data, it's time to transform it into the breathtaking images that we marvel at. This process is not as simple as clicking a button and having a beautiful image pop up. It's a meticulous operation that involves several steps. Firstly, we have the calibration stage. This is where we correct the data for any inconsistencies or errors that may have occurred during the observation. This could include anything from background noise, like cosmic rays or light from other sources, to instrument effects, such as sensitivity variations across the detector or thermal effects. The goal here is to ensure that the data accurately represents the observed celestial object, not the instrument's quirks or the environment's interference. Next, we combine multiple exposures. Often, a single snapshot cannot capture all the details of an astronomical object. To overcome this, astronomers take multiple exposures of the same object, each focusing on different aspects. These could be different wavelengths, different times, or different orientations. By combining these exposures, we can create a more comprehensive and detailed image. Lastly, we assign colors to the image. Now, this is where things get a bit tricky. Space telescopes often capture data in wavelengths that our eyes can't see, like infrared or ultraviolet. To translate this into a visual format, scientists assign colors to different wavelengths. This is done not just to make the image aesthetically pleasing, but also to highlight different features of the object. For example, assigning red to infrared data might reveal a previously unseen dust cloud, or blue to ultraviolet data could highlight hot, young stars. And there you have it. Through calibration, combination of exposures, and color assignment, we transform raw data into an image. But remember, this is not the end of the journey. Now we have an image, but there's one more step to make it truly stunning. The final step in the process is adding the artistic touch. In the realm of space imaging, art and science often cross paths. Just as an artist uses brushes and pigments to create a masterpiece, astronomers and graphic artists employ digital tools and data to breathe life into the raw, grayscale images captured by space telescopes. The collaboration between astronomers and graphic artists is a delicate dance. Astronomers bring to the table a deep understanding of the celestial objects and the data captured by the telescopes, while the artists contribute their skills in digital image manipulation and color theory. The first step in this artistic process is enhancing the image. This involves adjusting brightness and contrast levels to bring out the details that might have been lost in the noise. Astronomers and artists use highly sophisticated software to carefully tweak these parameters, ensuring that every detail, no matter how minute, is revealed. Next comes the process of colorization. This is where the magic truly happens. Contrary to popular belief, the colors in space images are not just picked randomly. They are chosen to represent different wavelengths of light or different types of data accurately. For example, in an image of a nebula, hydrogen might be represented in green, sulfur in red, and oxygen in blue. This technique not only creates visually appealing images, but also provides scientists with valuable insights into the composition and structure of the celestial bodies. The final result is a breathtaking image that is both scientifically accurate and visually stunning. Each image is a testament to the wonders of the universe and the incredible technology that allows us to explore it. It's a perfect blend of science and art, where each pixel tells a story of cosmic proportions. And there you have it, a stunning image of the cosmos, ready to inspire and captivate. From a distant light to a stunning image, this is how space telescopes capture the cosmos. It's a journey that starts with a mere glimmer in the vast expanse of space and ends with a vibrant tapestry of the universe as we know it. Let's take a moment to revisit this incredible process. It all begins with planning observations. Astronomers around the globe propose targets, carefully selecting celestial objects they believe will yield valuable data. These proposals are reviewed, and the most promising ones are accepted. The telescope's schedule is then meticulously planned out, ensuring each observation is timed perfectly. Once the plan is in place, it's time to capture the cosmos. The telescope swings into action, its gaze fixed on the chosen celestial object. It collects light in the form of photons, the most basic unit of all light in the universe. Each photon carries with it a wealth of information about the universe, waiting to be unlocked. But capturing the light is just the beginning. The real magic happens when the data is processed. Sophisticated software translates the raw data into a format that can be interpreted by scientists. It's here that the photons reveal their secrets, painting a picture of the universe that is both breathtaking and enlightening. And then come the final touches. The image is enhanced to bring out the details, each pixel tweaked to perfection. This is where the true beauty of the cosmos comes to life, in stunning images that reveal the grandeur of the universe. So there you have it, a glimpse into the intricate process behind those awe-inspiring images of the cosmos. It's a journey of discovery, of exploration, and of wonder. Next time you see a breathtaking image of the cosmos, remember the meticulous process behind it. And keep wondering, because the universe is full of mysteries waiting to be captured. Space has always been a source of mystery and wonder, and thanks to the marvels of technology, we are getting closer to understanding the cosmos. Every image captured by a space telescope represents an incredible journey of discovery, exploration, and wonder, just like we've shared today. If you've learned something new and fascinating from this video, show your appreciation by hitting the like button. Every one of us sees the universe in a unique way. We'd love to hear your thoughts and feelings about the cosmos and the wonders it holds. Share your opinions and ideas in the comments section below. Your insights might just inspire others to look up and appreciate the grandeur of the universe. If you're captivated by the cosmos and want to continue this journey of exploration, don't forget to subscribe to our channel. We have a universe of content waiting for you. Finally, the beauty of the cosmos is meant to be shared. If this video has sparked your curiosity or stirred your sense of wonder, share it with your friends and family. Let's marvel at the mysteries of the universe together, because the cosmos is not just out there, it's a part of us all. So, until the next cosmic journey, keep looking up, keep wondering, and keep exploring. Remember, every star you see in the night sky has a story to tell. Are you ready to listen?